we will be solving problems from the chapter waves. What do you call to and fro motion as oscillation? Substitute here, we get angular frequency and angular wave number. I'm also asked to find the phase difference between two particles. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In this new session, we will be solving problems from the chapter waves. I hope you have understood this session, practiced the session well, and the outcome will be the better understanding of the problems. The first one, a very interesting problem. The problem says a simple harmonic wave is traveling along a rope. A harmonic wave is traveling along a rope. The source generating these waves completes 50 to and fro motions. What do you call to and fro motion as oscillation? Very good. 50 oscillations is completed in 25 seconds. A trough travels 2 meters in 4 seconds. I have to calculate the wavelength, frequency, and speed of the wave. Now, time taken for 50 oscillations is 25 seconds. So time taken for 50 oscillations, 25 seconds. So time taken for one oscillation is how many seconds? Time taken for one oscillation is nothing but the period of the wave. So T equals 25 by 50 half, which is 0.5 seconds. So time taken for one oscillation is 0.5 seconds, which means therefore frequency is 1 by time, 1 by 0.5, which is 2 hertz. Now I have to calculate the speed of the wave. Now he says a trough travels 2 meters in 4 seconds. So distance traveled is 2 meters. Time taken is 4 seconds. So how will I calculate speed? The speed is distance traveled by time. So distance is 2 by 4. So which is equal to 0.5 meters. With this, I have to calculate wavelength. So we know V is F lambda, which means lambda is V by F. So 0.5 into 2, sorry, 0.5 by 2. So this is 0.25 meters. Again, simple comparison in this chapter. Very easily we get the results. The next one, students. A simple harmonic wave on a string is given by the equation y equals 0.6 sine 3.14x minus 3.42t. What is the direction of the propagation of the wave? How far does the wave crest travel in a time interval of 5 seconds? Now, the given equation is y equals 0.6 sine 3.14x 3.14x minus 9.42t. So this is the given equation. Comparing this with the standard expression, y is a sine kx minus omega t. So directly we compare. K is 3.14, angular wave number 2 pi by lambda is 3.14, or simplification says lambda is equal to 2 meter. Now, similarly omega is equal to 2 pi f is 9.42, or frequency is equal to, on calculation, 3 by 2, or time period is equal to 2 by 3 seconds. Now we know V is F times lambda. So on calculation, so F is 3 by 2 into 2, which is 3 meter per second. I will also have to calculate the distance traveled by the wave in a time interval of 5 seconds. So students, distance, speed into time. Speed is 3. So 15 meter will be the distance traveled in a time interval of 5 seconds. The next one, students. One end of a long rope hanging vertically and held in the hand is given a continuous to and fro motion with a frequency 5 hertz and amplitude 0.2 meter. A transverse wave travels down the length of the rope with a speed of 25 meter per second. Write the equation of the wave. Also determine the angular frequency and angular wave number. Now, the amplitude of the wave is given to be 0.2 meter. Frequency is given to be 5 hertz. Velocity is 25 meter per second. Now, therefore, what is the time period? 1 by f. This is 1 by 5, 0.2 seconds. How will I calculate wavelength? V is f lambda, which implies lambda is V by f, 25 by 5, which is 5 meter. Now I will use one another standard form of the wave, where y equals a sine 2 pi x by t minus t by capital T. So writing this, 0.2 sine 2 pi x by lambda minus. So this is the standard equation of the wave. Again, angular frequency. This is an assignment for you all. 2 pi by t and k is 2 pi by lambda. Substitute here. We get angular frequency and angular wave number. The next one, students. The equation. So y is equal to 6 sine. I rearrange that in the standard form. 4 pi t minus 0.2 pi x. Just multiplying throughout by 2 pi. So on comparison, sine omega t minus kx. Amplitude 6 meter. I need frequency and speed. So omega is 2 pi f So here it is 4 pi. So 2 pi f is 4 pi. So f is 2 hertz. Next, k 0.2 pi. So 2 pi by lambda, 2 pi. So lambda is 2 divided by 2 pi. So we get lambda as 10 millimeters. So amplitude is in millimeters. So V is F lambda 2 into 10 power minus 3, 20 into 10 power minus 3. If you look at the problem, I'm also asked to find the phase difference between two particles 2 millimeters apart. So phase difference is given as delta phi, 2 pi by lambda into delta x. Substitute here. So the answer is nearly 72 degrees. See, just using the standard equations of a progressive wave, we have solved problems here. Next problems on the chapter sound. Until then, have a nice time. Thank you.